Assalamualaikum and a very good day. We are from Group 15. Would like to present our slide on design of shaft. A shaft is a rotating machine that used to transmit power from a machine that produces power to a machine that absorbs power. A shaft usually has a circular cross-sectional area. There are three stresses that are induced on the shaft, which is shear stress, bending stress, and combined stress, like shown in the slide. Our design objective are: first, to design a shaft that has a high safety factor to avoid failure. Second, to determine the highest torque and bending moment that can apply on the shaft. Next, finally, to identify the number of cycles to failure of the shaft.
Assalamualaikum and hi, my name is Muhammad Aiman bin Muhammad Yusof. A160307 will explain about this figure. As you can see, the blue one is the shaft. The distance between them, around them, there is 2 components is 300 mm, and the D at point D is the spur gear. At the upside, the above spur gear, driving spur gear, there is driven spur gear that we connect to motor. The motor rotational per minute is around 1435. The diameter of the motor is 180, and the diameter of the machine is 430 mm. Okay, and the power transmitted, as we assume, is around 15 kilowatt. The pitch circle is 300 mm, and the ratio of tight and slack tension is 3. That's all.
My name is Muhammad Aminul Azin, and my metric number is A156406, and I'm from Group 15. So now I'm gonna explain about the static analysis and the calculation of the shaft. So this calculation is about shear stress, and then the torque transmitted by the shaft, and the bending moment in vertical plane and horizontal plane. So this calculation is from the ASME code, which is the American Society of Mechanical Engineers. Is one of the approach followed in design of transmission shaft. So the shear stress that we got from the calculation is 600, which is we got from 1435 and time by 180 over 430. So this the RPM of the main shaft is 600, which is the shear stress, and the torque transmitted by the shaft is 1110.38 Newton, which is we divide into two, torque by T and torque by S, as you can see in the slide. So torque T is equal to 3 times of torque S. So and then we divide the two torque, and then we got the torque for T is 1600 and 65.58 Newton, and the others is 555.19 Newton. So the bending moment of vertical plane is so now I'm gonna tell you about the bending moment in vertical plane. So the vertical plane in A, bending moment in A is 0 for sure, is because there is no distance, and then the bending moment in D is time by 300 for the distance, and then we got 246,000, and then moment B is we got 666,000, and then the moment C is 0 because after we calculate the plus minus, and then we got the 0. And the bending moment in horizontal plane, if we got is still the same. The bending moment for A is 0, and the bending moment in D is negative 238,000, and the bending moment in B is 0, and C is also 0. So this is the calculation for the static analysis for this shaft, which is you can see in the slide. There is many steps to calculate, and that's all from me. Thank you.
Hello, my name is Long Jerry, and today I will talk about the failure analysis. So we can use the factor of safety to determine whether the product or the shaft is safe or not. So the factor of safety is the ratio of the allowable stress to the actual stress. So a factor of safety of 1 represents that the stress is at the allowable limit. So if the factor of safety is less than 1 means that it is not safe, and then more than 1 means that it is very safe. So based on the shaft that we are going to analyze, so we substitute the yield strength and the maximum shear stress, and then we get 2.43 for the factor of safety, means that it is safe. And then for the infinity life, for example, 1435 rpm, which is equal to 23.92 cycle per second. And then for 5 years life, 1 hour operating time, 2 hours per week, which is equals to 1.9 million second, and then we times with the cycle, we get 4.6 times 10 power of 7 cycles to fail. So as you can see from the graph, when the stress amplitude is decreasing, the cycles to the failure is increasing, means that the stress amplitude if applied on the shaft is lower, then means that it can undergo more cycle before failure. And then the most cycles to the failure is at 80 to 90 megapascal.
Assalamualaikum and hi. Here I will explain about stress analysis. In this analysis, there will be von Mises stress, displacement and safety factor. Von Mises stress. This von Mises stress is a safe haven for design engineer. It is an important design criterion, and for this shaft, the maximum value of equivalent stress or von Mises stress is 11.41, which is it takes place at the spur gear between these two ball bearings. And as for this displacement, for the displacement of this shaft, the maximum value is 0.0009 millimeter, and also takes place at the spur gear. As you can see from the picture of the analysis, based on the contour color of the shaft, we can see that at this spur gear there are mixed colors of red, blue, green, and yellow. So it shows that the stress and displacement happens at the spur gear. And next, for the safety factor, for this shaft, the safety factor is around 12 to 15, and this value is meant that the value is safe, that the shaft is safe to be used.